looking at example 3, it says to find the area between these two curves, this one and this one, on this interval. So here we have to be a little bit careful about what the interval is telling us. And I'm going to demonstrate this with a graph. So just take a look at this graph from Desmos. The function, the quadratic one, x squared minus 2x, is the red one. The y equals 2x is this blue one here. We're finding the area between 0 and 6, but notice that they actually intersect each other at 0 and 5. So what we're going to have to do is two integrals here. Notice that the blue function is the larger one between 0 and 5, and then between 5 and 6, the red function is the larger one. So what we are trying to do is find this total area enclosed plus this extra little bit of area right here between 5 and 6. Kind of like this. Okay, so linear functions on top between 0 and 5, quadratic functions on top between 5 and 6. So keeping that in mind, let's see if we can figure out what this interval is going to look like. Alright, so we said linear function is on top first, so the total area is going to be the integral from, we said 0 to 5. The linear function is the larger one, that first interval. So linear function first minus quadratic. That will take care of the enclosed area, and then for the last little bit from 5 to 6, now they've reversed and the quadratic one is on top and the linear one is on the bottom. So this is what we're going to have to do to figure out what these what this total area is between 0 and 6. Alright, so let's simplify these a little bit. Get rid of the minus signs. Let's write them in descending order of power, so negative x squared plus 3x. Let's see, that's plus 3x and plus 2x, so that's plus 5x. And then for the second integral from 5 to 6, we'll just combine these like terms, so we'll get x squared minus 5x. Okay, so fortunately the antiderivatives are going to be very similar, so this first one, negative 1/3 x to the third, and this next one 5/2 x squared, and we're going to evaluate this one between 0 and 5. Second one, pretty similar antiderivative, except it's positive, so 1/3 x cubed minus 5/2 x squared. This one gets evaluated between 5 and 6. Okay, so we'll plug these in to both of them. Keep in mind on that first one, we're going to be plugging in 0 for the next term, so for the second term that gets subtracted off, so I'm not going to bother with that, because when you plug 0 in here, you're just going to get 0. This one we are going to have to plug in two different numbers. So once you do all that, you get this. So again, notice plugging in 5, I get that. Plugging in 0, it's just 0, so I'm not going to do that. This is the second part here. Plugging in 6 is that, and then plugging in 5, subtracting that off. That's this part. So that's the fundamental theorem. Simplifying this, you get this, which, as you notice, you get a couple of these, minus 125 over 3, minus 125 over 3, and then plus 125 over 2. So that's going to show up twice. Simplifying all this, you get your final answer of 71 over 3. So the total area between these two curves on this interval, including the enclosed part between 0 and 5 and the extra bit from 5 to 6, 71 over 3.